Well, welcome everybody to this afternoon's AMPC webinar. This afternoon's webinar is on the digital tool for assessment and design of integrated wastewater treatment and resource recovery at red meat processor plants. The red meat processors are often considered the original recyclers, and they utilise up to 98% of the whole animal being processed and deliver hundreds of high-value products. The wastewater generated from processing these valuable products is the last frontier in 100% bioresource recovery for red meat processing plants. This webinar is on the project progress, and the project is developing a tool to aid processors in the design of fully integrated wastewater treatment and resource recovery. Integrated design addresses water recycling, nutrient and organic solids recovery, energy recovery, and reprocessing and producing bio-based fertilizers. Today we have Dr. Fabiana Tessoli of Tessoli Consultants as our project provider and our presenter for today. Dr. Tessoli was recently awarded Western Australia's Water Professional of the Year. She represents Australia at the International Water Association Anaerobic Digestion Group. She works closely with researchers in Europe and is a peer reviewer for technical conferences. So I'd like to hand over to Dr. Tessoli to go through our presentation. Thank you.
Hello, good afternoon. Thank you. Thank you, Matt, and good afternoon, everybody, and thank you very much for showing up. Today I'm going to talk to you about the result of about 18 months of work we are developing with AMPC. We have developed from there a model based on several case studies that we've been assessing in the red meat industry. So the idea really is to start driving digital circular economy in the red meat industry and make it more feasible for people to assess the potential of what they could produce. So the main drivers that originated this project include environmental compliance. So lots of abattoirs still have to improve nitrogen and phosphorus removal, like nutrient removal in general. And that has as a side effect an increase on energy consumption and carbon footprint consequently. Many of the facilities now also are seeking for energy self-reliance, being out of relying on the grid or external providers of electricity. At the same time, adopting renewables, heading into the net zero carbon by 2030 goals of across the board in the industry, right? So that represents a little bit of a paradigm shift. Is not anymore treating wastewater and organic waste just as a waste, but is also trying to recover value from them, right? So how can we benefit from your waste instead of just treating them as something unwanted? What we notice across the board in the industry, there is a little bit of a shortage in skills and expertise. So there is not too many people that understand how to do this kind of work. There are not enough consultants that could be developing this kind of concept design and feasibility in Australia. There is a very strong need for innovation and research and development to get into a point where you can really reuse all these wastes, right? And there is also a need for an alternative business model, because we are talking here about a significant capital investment. So because of all these things, we decided to create a tool where we can provide very quick answers for an initial assessment. So the facilities can very easily, as you're going to see a bit later, assess how much energy, how much water, how much fertilizer they could be producing from their operations currently. So this was all based in an integrated system, and the integrated system is aims to not allow anything goes to waste in a processing plant. You can start by the processing plant. You have the liquid waste, which is the wastewater, and then you have all the solid byproducts like the punch, the manure, the fats, the gut contents, undigested feed, and for example, sometimes the soft offal, depending on the process, right? So what we created here is a system where you separate wastewater to one side to recover very high quality water, and we are talking here about class A water or high risk of exposure water. that is really suitable for recycling in many applications, not exactly directly into the meat production, but irrigation and washing and all the applications on site. And in the other side, we have all the solid streams, including the sludges, to produce biogas in an anaerobic digestion plant. And here we are talking about enclosed reactors and not ponds, to produce power, heat, CO2, lots of byproducts, and biofertilizer, right? And I just want to highlight that this is not the same as the common cover-related lagoon systems. It's a very different system because it separates the wastewater liquid streams to maximize the recovery of very high quality water and all the very high energy streams into the AD plant. That improves efficiency both ways, into the energy production and the water recovery. I'm going to go through quickly on the process description here, and I'm not going to stick too long into that because the goal today here is to talk about the digital tool itself. But later, I'm happy to take more questions if you guys didn't understand something. Okay? So to start with the wastewater treatment, the main goal here is really to recover water. So we have a sequence of processes that start with a very, very good pre-treatment where we remove up to 95–96% of all the suspended solids. In this stage, we can also remove nitrogen because you are taking the protein, the solid part of nitrogen. So you enter the wastewater treatment process with a very clarified water, mainly with dissolved contaminants or nutrients. And then that goes into a biological nutrient removal stage, which can be a conventional BNR, or it can be a more efficient Anamox. That is something that can be flexible. And then that's followed by polishing for removing phosphorus, and then disinfection in a double barrier using UV and chlorination. So you eliminate pathogens, you eliminate any problem, smells, virus, everything. So you end up with a very, very high quality water. There are a few examples of companies that have been doing this for a very long time, and I went to visit them twice, once in 2018 and then just recently now in June. So people are doing that, and you can see we can have here very, very good quality water by adopting this principle. So this is one abattoir in France, and then another one as well. Both of them are operated by Veolia. So what I'm talking, sorry, yeah?
Sorry to interrupt. On the screen that I'm seeing, your presentation is expanded. It's enlarged, and it's taking. I can't see the full page. Maybe can you reduce the size of the presentation, or
how is it like this? You'll be a bit of. Let me see, like this. Can you see it better?
I can only see the top half of the page.
Ah.
I think it might be your screen, Matt, because it's okay on mine.
Oh, good. Thanks. Who is that?
Anybody else having problem?
It looks fine on others. So sorry about
it's Kendall's,
sorry.
Okay, sorry, Matt. So these are the two examples I'm saying on how this kind of system is already used. So what I'm saying here, I'm not inventing anything new on the wastewater treatment side. We are just using systems and processes that already exist and integrating them to maximize the benefits, right? The second part of it is the biogas plant, where we have a pre-treatment also, where we condition the liquids and the solids in homogeneous mixture, and they go to the AD plant, followed by the energy recovery, which in this case here for this project is a CHP engine, where you can recover heat and power, but there are different options you can work as well. And in the end of after the digestion happens, we have the watering step. So our digestate doesn't go out of the plant as a liquid, which is being a limiting factor for many plants at the moment. So we have a dewatering step to produce a biofertilizer after this. So this is another example for a plant that I visited in Europe recently, and this is an abattoir who is fully powered only by their waste, and that's one of the few places that only treat meat waste. They don't mix co-digestion with anything else. and they have been very successful operating since 2003, so it's almost 20 years, and that's financially very, very viable. The final step is the biofertilizer production, which we are considering a biochar, and the reason why we are talking about biochar is for safety. So you end up with a product that's very, very safe from the bacterial point of view. There is no pathogens left there because the material is processed at 400 degrees. And also there is no residuals of antibiotics or medicines or hormones. So that's a very, very high value product that can be obtained after the digestion. So we have an example here in Australia right now, the Logo City Council in Queensland, they are using that for processing their waste, and they're being very successful both in carbon reduction and energy recovery and the reduction of the amount of waste they produce, right? So the methodology we had here to use this integrated system to transform it into a model is that we had 7 cases that are anonymous in Australia. We designed this integrated system for each one of them. We used BioWin to validate the process design and the sensitivity, meaning how much extra load we can add and what's the robustness of the process. We developed cost estimates and economic analysis for each case based on suppliers' quotations and cost curves as well. And then we prepared very large Excel spreadsheets with correlating all of them to create curves that we could expand and extrapolate to different sizes of abattoirs. We ended up having to code everything in Java because the spreadsheets were getting really large with 20 different variables we had as an input. And that JavaScript is feeding the online calculator. That's the interface we are going to see soon. So in regards to classification, we use the AMPC classification between small, medium, and large. And then we translated that from production into wastewater production. So we have 3 different types of systems. The small systems, the flow is under 750 kiloliters a day of production of wastewater. And then medium systems are in between 750 and 1500. And then large systems above 1500 kiloliters per day, right? But beside the amount of wastewater, we also noticed that there are very variable water quality as well, wastewater quality. So we end up classifying the wastewater quality, which we call wastewater strength, into low strength. And these normally are abattoirs that have higher water consumption, so they have more diluted flows. And then moderate strength, which is many of the abattoirs are falling in this category. And then the high strength. The high strength normally are the sheep and lamb producers and the people that are more efficient on using water. So there is a correlation in that. So we end up with a small matrix here. The columns represent the flow and the rows the strength. And each of our case studies fit in one of these boxes. So we managed to get a good spread across the different categories. And we know only 7 abattoirs. They are not the real truth, but I think they are very representative of the Australian reality to start the model. After we had the engineering and the cost estimates, we had an economic analysis. So how can we generate value and revenue from this project? So the first thing we did was this is an example of what Western Australia reality is. What's the cost of non-potable water in the area of the abattoir? So for example, for one of the cases in the southwest here in Western Australia, you can buy water from 10,000 a megaliter if you buy it from tankers, up to for free if you go and get from a dam or somewhere or groundwater, right? So what we did a benchmark study on what's happening in the area and how much people are paying for it, for construction, for irrigation, or for cooling down piles of wood chips, lots of applications. So we got out to $1,200 per megaliter for non-potable as an amount that we consider conservative, because well, there are people paying 10,000, so we stick to the 12,000 as an input, 1,200 as an input. The second one was the energy, and that's been so interesting because since we started the exercise, the the whole energy scene changed so much, and the value of gas over east especially went through the roof, right? So also what you can do with the biogas is also evolving very fast. So we stick into the CHP engine electricity and heat flow only, and assuming $20 per gigajoule, assuming that we are going to use electricity and heat. But there is also all these opportunities that derive from biogas that can be assessed, right? And right now, the CO2 recovery, for example, is becoming the new star. Everybody wants that as well. The other thing was the biofertilizer costs, and depending on how you market it, it can be up to $18,000 a ton. It's being in high demand. There is lots of people wanting biochar for soil amendment and soil improvement. We've been talking to entities like Greening Australia, for example, on the appetite of taking it. So from $18,000 per ton, we decided to go down to $1,600 per ton, just as a conservative assumption to work out the feasibility. The other thing is the cost of sludge disposal. So that is very different depending on the states. For example, in Queensland, we have the end of waste framework, which is, I think, the most advanced regulation we have in the country. Up to, you have in WA costs that change between 180 to 300, depending on distances where you have to transport the waste. So we are assuming 250 per ton as a national average. And then carbon credit is another area that we need to, it is constantly evolving also. The carbon credits value is being increasing quite a lot lately. So there are two scenarios you can consider here. Those facilities that are exporting to Europe, we can adopt the European carbon credit value, which is 50 euros, around $96 per ton. Or you can adopt the Australian values that's more around 35. So that's another thing we can also vary in the model. So all these things, they served as an input to create the model for that you're going to see now. From now, the next steps is to run a live workshop for AMPC members. So we are going to be open to have individual conversations with each of you that Matt is going to give details later. We are going to produce a document that gives you the guidelines on how you can use the tool, and then move on from the beta version to the official launching. And we are right now on a stage where we are reviewing all the assumptions because of all these changes in the energy market. Especially, we are refining all the assumptions, refining the costing to launch the final version a little bit later. So after this, I want to pass to my colleague Gustavo to present to you the tool, but I just want to know if you have any questions for now. Anybody has any question?
Yeah, Fabiano, the rest of the attendees can't use their mic, but I've got some questions to read out for you.
Okay.
So there was a question, does the tool include a cost comparison of traditional lagoon versus continuously stirred tank reactor?
No, we're not comparing with the existing systems, and that's because it would be very laborious to understand each and every of the 138 sites we have in Australia, and each of them has different constraints. So this is assuming you're going to fully implement a new system. It's not comparing with anything else. No.
Thanks, Fabiana. And I might remind members that there already is a tool, another tool that we have that compares traditional lagoon with other types of anaerobic digestion. But that tool is different in that it doesn't talk around integration that we're talking about here.
Yeah, that's just part of things. Yeah.
Yeah, thanks. There was another question. The tool assumes $20 a gigajoule as a value from the biogas. The tool assumes as a value from the biogas. That question is sort of not making sense to me, but can you talk about the fact that you can alter the assumptions there, Fabiana?
Yeah. For example, here in Western Australia, gas is a lot cheaper. It's $6.49 or something like that at the moment. So there is you're going to see soon when Gustavo goes through it with you, there is a window where you can enter all your own costs. For example, if you're not being able to sell the water, you can enter zero there. There is all the parameters can be changed according to your reality. So these assumptions I put there is just for the standard case. So average conditions and standard values, but everything can be modified.
Thanks, Fabiana. There was another part to that question around the uses of the recycled water. What would they be suitable for? Okay, so in theory, the recycled water can be used for any purpose that doesn't touch direct contact with the meat being produced in a red meat processing facility. There are still conversations and negotiations with AQUIS about what's the extent that the water can be used inside the plant. So I would recommend for now that you use for external uses for cleaning trucks, cleaning the receiving areas, lairage areas, and irrigation or dust suppression, any other use. Or you can also use that water for chillers, for cooling systems, and yeah, any non-potable application that you might have. All right, thanks for that, Fabiana. There was some other questions coming in. I'll leave them till the end, perhaps. And there was quite a lengthy question that I won't go through, but we can come back to that person after the webinar as well. So I'll hand back to you, Fabiana. Okay, so now I'll hand back to Gustavo, who is going to present the digital tool itself.
Hi, hello everyone. Thanks for attending the webinar. The tool starts with a dashboard, and the dashboard is based on average conditions. The dashboard, it intends to be a rapid assessment where by dragging the arrow at the top, the user will input the combined cattle and beef production in tons of hot standard carcass weight, and the tool will provide the outputs of the system implementation. So we can see here the carbon emissions reduction was accounted, waste diverted to landfill, recycled water production, energy production, biochar production, as well as the economic analysis, the financials from the system, the costs for implementation of wastewater treatment plant, the biogas plant, a biofertilizer plant, operational costs as well, and the financial returns of the case. So that's a really rapid assessment based on average conditions. And then the user has an option to continue and design their own system. So we'll go ahead and click on Design My System. The following page will be to enter the details. So here, company name, name of the user, email address, mobile number, street address, postcode, state. And there is also the option to enter the amount of heads processed per annum in beef, sheep, and lamb. But the user has to input the total production for combined beef and sheep in terms of 1,000 tons of standard hot carcass weight. So here, for the sake of this exercise, we will adopt 70,000 tons per annum for combined production and continue with the design. The following page, the user will have an option to select appropriate effluent strength based on their wastewater analysis. So as Fabiana mentioned before, we have categorized in 3 different strengths: low strength, moderate strength, and high strength. And also the user can select other and enter their own parameters for average and peak analysis. We will adopt a moderate strength here, and continue with the exercise. So click on continue again. Now at this section, it's where the user can enter the value of the byproducts of the plant. The user can either adopt the standard values that we have considered here, or enter the values that best suit their scenario based on location, etc. So we will start with the standard value and go ahead and calculate the system. Okay, from here onwards, there are only results showing up on the screen. The first page of the results is the system classification. So the facility was classified, the red meat processing facility was classified as a medium size. The type of system recommended is the fully integrated system, as Fabiana has mentioned before. The average wastewater going into the plant is showed here, and the approximated footprint as well is here. So we can go ahead and click on the next button, and then this page will show the resource recoveries by products. For example, the recycled water production, the energy production in form of biogas, the biochar production, the overall carbon emissions reduction, and then the recycled water intensity, which is in kiloliters per ton of hot standard carcass weight, in average 90% of the input. The energy intensity in megajoules per ton of hot standard carcass weight, and the biochar intensity, how many kilograms of biochar can be produced by tons of hot standard carcass weight. There is an option to use the button to recalculate. So if the user clicks on recalculate button, that the user will be directed to the strength page, but that's not what I want to change. Or you can change the value inputs and then recalculate the system. So I didn't change anything, so I'll go ahead and progress. The next page in the sequence presents the costs of the system implementation and operational ones as well. So there is the breakdown for the wastewater treatment plant costs, the biogas plant costs, and biochar plant costs, the total capex, and the capex intensity. Also, the operational costs breakdown and total is presented here. So if we go ahead and click next again, this is the last page of the tool where the financial analysis is presented. So that includes the revenue from the byproducts of the plant in dollars per annum per type of revenue, and their intensity as well, and the combined revenue and the revenue intensity. So in this case, we have $71 per ton of total ton of hot standard carcass weight. However, if we go back to the recalculate button, keep moderate strength, and let's say in Western Australia the energy is cheaper, so we will keep the other values the same, but we'll change the energy from 20 to 650, and then we'll recalculate the financials. The system won't change because the strength hasn't changed and the throughput capacity hasn't changed. But as we progress to the financial analysis, we will see that the revenue intensity has changed due to the change in the price of energy, and also the payback term has increased a little bit. So this is one of the features of the tool that might help to the users to find the best, the most adequate conditions for their own state. And the assumptions for the economic analysis are here. So nominal discount rate, escalation rate, tax rate, and post-tax cash coefficient. And the last feature of the tool is to generate a report. So I'll go ahead and click on the generate report button. Okay, there is a report. The report will present the background information of the integrated bioresource recovery system, which is the wastewater treatment plant, the biogas plant, and the biofertilizer plant. And the project inputs and outputs. So the information we have inserted at the start of the digital tool, for example, our throughput capacity, which is 70,000 tons of hot standard carcass weight per year. The total annual kill of beef and sheep, and as well as the outputs of the system will be presented on the summary report. In the following page, there will be the graphical representations of the system where the wastewater treatment plant is shown, the biogas plant is shown here as well, and the biochar plant at the very end here. The following page will be present the capital investment, operational investment, and the revenues of the system, and the remaining data of the economic analysis. And in the last page, the return of investment of the system. So this is a good one to bring to the Friday's meeting and discuss with the board. And I guess that's it from my side.
So some more questions. Just hang on a sec there, Gustavo and Fabiana.
Yeah. We are here.
So are there any service or business models for the integrated wastewater treatment as part of this project?
What we are offering together with the AMPC is to have a one-on-one with the members. So we are happy to go through the model considering their own reality, their own energy costs, their own water uses, and then have a more refined outcome from the model. But then from there onwards has to be then another project, maybe a plant initiated project or something like that to move forward in implementing. Yes, it's happening already with a couple of producers.
That there's a core project to look at potential investors and potential business models that might suit this.
Yes, exactly.
Yep. Thanks, Fabiana. There were some other questions around the biochar assumptions, and I think there's two of them that are related. So one was saying that further information on how the value of biochar has been estimated, and I think a related question was biochar reference plant in Queensland, actual value of biochar between $10 and $50 a tonne. So yeah, do you want to comment on that?
Yeah, that depends a lot on how you market your product. For example, you can actually, in some cases, you need to give it for free, especially if it's human waste biochar. And if you market it in smaller packages, and depending on who is your consumer, that price can be from giving away up to $20,000. That was a market exercise we did, and we are right now refining to another project specifically on managing and reprocessing wastewater sludge from abattoirs, which is very different from human wastewater.
That's a good point, Fabiana. Thanks for that. Another question there, what factors have been included in the OPEX calculations?
Okay, so in the OPEX, we use a standard percentage from the CAPEX. So we are considering operation costs from energy, chemicals, operations, depreciation. It's all these things incorporated into that percentage.
Okay, you're answering too quickly. That's fine.
And
Yeah. Another question there, are you able to change your UOMs for the intensity factors?
change, I'm sorry, what, Matt?
I guess assumptions for the intensity factors.
Yeah, it is basically the intensity is calculated by the output. Let's say water intensity. You know how much water you'll be able to recover through the process, and then you have your number of Q, right? So it's dividing the total production by the number of Q, the tons of hot carcass weight. So the only way to influence that is to either change the Q or change the production of what you are calculating.
Very good. Thanks for that. Another question there was referring to the Großviertner St. Martin plant in Upper Austria. I didn't hear you mention that, but they said what is the processing capacity of that plant?
I can go back to the slide. There I have the details here. So they process pigs and cattle together, 550,000 pigs and 50,000 cattle per year. Yeah, that's it. So they use everything: blood, rumen, colon content, grease, everything.
Right. Thanks very much. Another question there. When reusing offal or DAF material through AD, does the tool consider any losses of revenue which otherwise would have been generated through selling tallow?
Not in the model, no, because what the reality is that most of the plants that are selling it to tallow plants, it's done outside, and they're just basically paying for transport. They're not making so much money from that, so that's not considered. No.
Thanks, Fabiana. Another one there. Have you investigated the model of running this plant as a JV with an external operator via an offtake agreement, i.e. gas and water?
Yes, we are absolutely investigating that, and that's part of the scope of the new project we are developing with AMPC, which is really develop a business case that's very robust, considering the integrated system in average Australian conditions. So we are doing in detail 2 abattoirs, one in the West Coast and one in the East Coast, to get to a very, very robust number in terms of return on investment, payback time, so we can negotiate with private sector on the business model, you know, as a service. Yes, and there is already a couple of interested companies on that space. Yeah.
Thanks, Fabiana. Yep, it would be remiss of us if we didn't do further research on how this is going to be funded. There was another question there. Gustavo went through this a bit, but what are the typical ROIs identified through the model?
Well, the return on investment, it's around in 5 years, and it's around 3 to 5% a year, depending on the bigger you are. Of course, you get scale, so you get better return on investment. So yeah, around 3 to 5% per year. Depending, there is another important thing is how you implement it. So if you want to stage it for the capital investment, which some plants are considering, first wastewater and then biogas and then biochar, you might take 5 years only investing, and that will delay your returns. But if you can really have the cash to start everything from beginning, so you probably start having revenue from the year 2. So that's all how you balance the investment as well. That affects a lot on your return on investment.
Thanks, Fabiana. And one final question there. When is the final report due?
Oh yeah, due by the end of August. So we are working on that right now, on finalizing, and we are welcoming any feedback from this webinar also to incorporate into the final reporting.
Fantastic. Thanks for that. So thank you, Fabiana and Gustavo, for that excellent presentation. And thank you to all the attendees for those good questions. So I just remind all the attendees that if you didn't ask any questions that you wanted to, or you'd like to talk further on the tool, then you can always contact your co-innovation manager, or you can contact the AMPC office, and we can arrange some time for you to talk with Fabiana about your queries. Like any tool, these are good, on screen, online, but they don't get any take up unless we offer some one-on-one consultation with the provider of that tool. So with this tool, like we do with the other tools, there will be, at the completion of the project, an ability for members to have some one-on-one time with Tessely, and to run through the tool, and to have some written material at the end of it, as far as whether it's applicable and what your next steps might be. So you have a better idea around how progressing with that sort of infrastructure. So if there's no further questions or comments, I'd like to thank you all and Tessely for your presentations, and we look forward to catching up again next time. Thanks.
Thank you.
Thank you.